Have you ever tried to use just record types to design a domain model? If you have, then you know what other programmers have already noticed, that your code is suddenly becoming 2 or 3 times shorter, that the number of bugs drops by the order of magnitude. Yet many programmers are still afraid to try that. I will try in this video to show you the building blocks of record types and what comes with them, but the central theme of this video is the feature that is coming with C#14, which is finally making record types complete. Their last missing superpower is here. Therefore, I will now show you how to design a system of record types with behavior, with construction, and how to use them. And I hope that that will be enough to make you try the record types on your own. This is an example record. It only has 3 properties, a GUID ID and 2 strings. It represents an author of a book. Let's try to use it. I will create 1, 2, 3, 4 objects, and you will immediately notice a problem here. There is no validation. I can put whatever I want here. I can create a clearly invalid object here, and the record itself will not stop me. So there comes the first lesson about record types. We need a factory function for each record type. It would be a static method which receives the parameters, validates them, and possibly creates a new object. This static method is accepting the first and last name. The last name of the author is optional, but the first one must be non-empty, non-null. And only when that happens, the new object will be created with the newly associated GUID. This is what you would normally put into a class constructor, but in record types we usually create a separate factory method as the static method. So let's see how we use such a factory method. We say author creation.new and then give the parameters. Well, this is really not what I wanted to have. What is this author creation? What is the purpose of introducing another class just to say that I want a new author? We can now associate a static factory method directly to the type, not an object. And so this static method, new, becomes a method, a static method on the type author. You can add other factory methods too. The restore static method accepts a pre-existing ID of an author and the rest of the parameters, and then does the validation again and creates the object. There is some code duplication here. You would apply traditional methods to get rid of it. A new possibility is to add extension methods that are private and only useful in this creation class, only visible to the factory methods. I have removed code duplication by introducing a utility extension on the string type. Let's get back to the place where I used the record and let me show you what it will look like now. Author.new. Well, this looks nice. This is descriptive, readable. If I applied it to other instances, this code is easy to understand. The last case would fail this time because the new factory method is performing validation, so I will comment it out. And this is how we create instances of records today. Then come the rest of the story about records. Records come with built-in non-destructive mutation syntax, the with expressions. Each with expression creates a new instance, but it comes with a well-optimized constructor that only copies what remains the same in two objects and modifies what is new, what is actually modified inside the object. Even though you need to pay the price of constructing a new object, there is no price lower than using the with expression. So we have the definition of the record, the construction of the valid record instance, and non-destructive mutation. The rest of the story is behavior. This would be an extension method on the instance of the record type. That is where the next great feature of C# comes: switch expressions. Not switch statements, switch expressions. An expression is evaluated and it returns a value. And so the principal way in which you will calculate with the record type is to map patterns, map the object against a set of patterns. Look, I'm mapping the first and last name here. The request is to construct a printable label. And here's the pattern: any first name and an empty last name. That is just the first name. And then the first and the last name, assuming that the first pattern was not matched, which means that the last name is a non-empty string. Then I would just format the resulting string. This is the principal way in which you would attach behavior to a record type. The benefit you get for free from doing things this way is that this extension method can be defined at the place where it is needed. You would define methods on the class traditionally, but then the class would be burdened with methods that nobody cares about, except maybe one portion of your code. Well, now the extension method would be defined in that portion of code that needs it. All right, this is another example, the book class, where you can see another traditional concept in records using immutable classes. You can extend the book record type with your own non-destructive methods, like adding a new author. I'm writing this method specifically because I want to show you one important concept when working with records and immutable classes in general. For example, if the author is already present in the book, then just return the book object you already have. You don't have to create a new object if there is nothing to change in it. That's the benefit of working with records which are immutable by default. Only when there is the reason to mutate, create a new object using the with expression and return that. The new instance will reuse everything from the old object that didn't change, so it will be very efficient given the situation. One last piece of behavior, formatting a book into a label. It fits at the same place where we format the author. You see, that is another benefit from using record types which you enrich with extension methods. You define those extension methods together as a bundle, so you can extend both the author and the book in one place, not in two places as you would do with classes. That will be another pattern matching expression, but this time I'm going to match patterns against an entire collection. You can do that as well. And I will show you now how you can do that, but before that, let me ask you a favor. This channel is free thanks to the people who support it on Patreon. If you like what you have learned from this video and other videos on my channel, then please consider joining the growing community of supporters on my Patreon page. Thank you for your support. Now let's see how we can capture the structure and the content of a collection using the switch expression. You can match an empty collection. If there are no authors, then just return the book's title. You can match a collection that has a single element and capture that element and use it in the expression on the right. This is very rich, but the wild patterns are only coming. You can match a collection that has two elements, capture both of them and use them in the right-hand expression. Or match a collection that has a first element and capture it and has 0 or more elements beyond that element. But now, since the single variant has been captured, it's obvious that it is not 0 elements. Since the first and second pattern has not been matched, it is obvious that it is not the first followed by just one element. It is obvious that this last pattern is matching a collection with at least 3 elements in it, and I'm only capturing one of them, the first one, because I don't care about the others. I only need the first one in the right-hand expression. The C# compiler is powerful enough to understand that this list of patterns is exhaustive. There's nothing I haven't covered with these 4 patterns, and therefore the warning at the switch expression has disappeared. This is the principal way how you write behavior on top of record types. And let's quickly see how we can use this. You can create a book from the static factory method, or I will create 2 more authors. You can create a book with no authors, but then use non-destructive mutation to add one and the other. There will be 3 books here, but I will only take the reference to the last object created, and it will have 2 authors in it. I will use those 2 label extensions to print out these books. I will run the application and you can see that everything is working fine. These are all the elements of working with records in the latest C#. I would really love to see you trying them out, because as I promised, your code will be shorter and there will be less bugs in it. What else can you ask for?